This is Chapter 6, problem number 67. A car rounds a banked curve as in figure 6.6. The radius of curvature of the road is r. The banking angle is theta. And the coefficient of static friction is mu s. A. Determine the range of speeds the car can have without slipping up or down the road. B. Find the minimum value of mu s such that the minimum speed is 0. C. What is the range of speeds possible if r equals 100 meters, theta equals 10 degrees, and mu s equals 0.100? This is the figure for the problem.
This car is going around a curve, or a bank in a curve. The curve is given by radius r, and these are the forces acting on it. If the car is about to slip down the hill because it's moving too slow, the force of friction acts up the hill. The normal force acts perpendicular to the surface. The centripetal force pulls the car inward. The gravity pulls the car downward. To solve this problem, we need to break up this diagram into its component forces. F sub F is the friction, mg is gravity, n is the normal force, and Fc is the centripetal force. To break these up, we already have two that are already in x and y directions. Mg is in the y direction, the negative y direction to be specific. F of C is in the negative x direction. To divide FF into two parts, this becomes F, and this becomes FF sine theta, given that this angle and this angle are congruent, which we know because this is parallel. Simple geometry. We split n up into two parts. This becomes n cosine theta, this becomes n sine theta. Now that we have everything in either an x or a y direction, we can add them together. Since the car is not accelerating upwards or downwards, we can assume that the forces in the y direction are all equal to 0. So n cosine theta plus friction sine theta minus mg is going to equal 0. You can tell this from looking at the diagram. N is upward. N cosine theta is the upwards component of n. FF sine theta is the upwards component of F. Mg is the negative component of gravity. We need to solve for n. Now, the first thing we need to note is that force of friction is equal to n, the normal force, times mu s, which is the coefficient of friction. We sub that in. N cosine theta plus n mu s sine theta minus mg.
That doesn't even know physics that well. Don't give me one.
Move the mg to the other side, factor out the n. Now, when we get over here, we're going to do something a little interesting. We're going to multiply the sine part by 1, cosine theta over cosine theta. What this will let us do is factor out the cosine theta. And sine over cosine is equal to tangent. Mg equals n cosine theta, parenthesis, 1 plus mu s tan theta, end parenthesis. Divide both sides, and you get n is equal to mg cosine theta, 1 plus mu s tan theta. Now, for the forces in the x direction, we do something similar. All the forces in the x direction are equal to 0, since it is neither accelerating to the right or to the left. N sine theta is the horizontal component of the normal force. F cosine theta is the horizontal component of friction. Fc is the centripetal force. Rearrange, and remembering that FF is equal to n mu s, we get this equation. Fc is equal to n sine theta minus n cosine theta. Factor out the n and substitute mv squared over r for Fc. This is going to be v min, because it's the minimum velocity in order to maintain a position on the bank of the curve. going to do the same thing earlier. We're going to add the cosines in here so we can factor them out. Thus, the equation becomes, this part of the equation becomes tan theta minus mu s. The rest of the equation, we move the r and the m to the other side. Now, n we already solved for. We found that it was equal to mg over cosine theta, parenthesis, 1 plus mu s tan theta. We factored out the cosine of here. Now to simplify the equation. V squared is equal to r times g times the fraction tan theta minus mu s over 1 plus mu s tan theta. Take the square root. The minimum velocity for the car going around the bank of the curve is given by this equation. Square root of rg tan theta minus mu s over 1 plus mu s tan theta. Part B asks us to find the same thing as Part A, except for one difference. The car is traveling faster and is about to slip upward. Therefore, the force of friction will be moving in this direction to maintain its position on the slant. This is a diagram of all the forces acting on the car. This is representing the car. Normal force, centripetal acceleration, or centripetal force, force of friction, force of gravity. Again, we break it up into its component parts. N sine theta and cosine theta. Fc, which is F centripetal, F cosine theta, FF sine theta. And again, mg. Again, we need to find all the forces in the y direction. Since the car is neither accelerating upwards or downwards, we know that sum of the forces in the y direction is equal to 0. 0 equals n cosine theta minus ff sine theta minus mg. The negative represents that the force following it is going downward. N cosine theta means the force is going upward since it's positive. Rearrange the equation. mg equals n cosine theta minus n mu s sine theta. We get n mu s from force of friction. Again, factor out a cosine from both here and here. It gives us this equation. mg equals n cosine theta 1 minus mu s tan theta. Solve for n. N is equal to mg over 1 minus mu s tan theta cosine theta. Now, we need to find the forces in the x direction. It's equal to 0. Therefore, negative sine theta minus f cosine theta minus the centripetal force equals 0. Fc equals negative n sine theta minus mu s n cosine theta. Again, we pull out the n and the cosine and the negative, giving us the equation Fc is equal to negative n cosine theta tan theta plus mu s. Fc is the centripetal force, given by mv max squared over r. Multiply both sides by r over m. At this point, we can cancel things out, and we substitute n into this part for n. That should be a positive, my mistake. Therefore, the square of the maximum velocity is given by this. Take the square root, and we get this equation. Part C asks us to find the maximum velocity and minimum velocity under a certain set of conditions. The conditions given are that the radius of the banked road is 100 meters. Mu s, the coefficient of friction, is 0.10. Theta is 10 degrees. Plug in your numbers. It's pretty simple. Vmin is equal to this, which equals 8.57 meters per second. This is the equation from part A. Vmax is the equation from part B. Plug in your numbers, and you get 16.6 meters per second.